Hi friends, welcome to my channel. Today we will be discussing on the challenges faced in the distributed systems and their possible solutions. So distributed system has the application to scale, improve performance and enhance the system performance by leveraging multiple computers work together. However, designing the distributed system comes with a significant challenges. We'll discuss about the following challenges faced by the distributed systems and their possible solutions to solve those problems. So one the first challenge is the communication challenges. So when in the distributed system, multiple nodes interact with each other, so there could be communication challenges. The key issues, the communication challenges are packet loss, out of order delivery, and the security risk. So packet loss is nothing but when the data sent from one of the node is could be dropped due to network failures. Okay, and out of order delivery is like the messages sent from the node reaches the node at a different times or is out of order or it is out of sequence. And then the security risk is like data transmitted between the two nodes is not secure. If it is not secure, can be intercepted by third party, and it could lead to data loss or the any other losses in the communications. So it could be man in middle attack or something. Okay. So the techniques to handle the communication challenges are using TCP. So TCP ensures that the messages are delivered without the loss of the packet. And if there is any loss, there is a retry mechanism, retransmission, and the ordering is ordering of the messages. Like the messages are delivered in a right order, which is received at the other node. TCP guarantees that the messages arrive in a sequence and without loss. So how do we secure the communication? Using TLS, transport layer security. Encrypting messages using TLS ensures that communication between the two nodes is secure and then prevent data loss or data interception. Okay, TCP based encryption is used in HTTP. TLS based encryption is used in HTTPS, packet transmission, and security. So service discovery with the DNS. So in distributed system, we know that the nodes are in the different areas. So identifying the resources to call that particular service is one quite challenge. So we use service discovery. So by using the DNS, so when we call the DNS server, the node to call the API is identified without hard coding the IP address. So you can directly call that service by calling the DNS. It would give you the DNS name for that server, and you can communicate with that. So this is to avoid the communication challenges. So in AWS, we see AWS Route 53 and Kubernetes Service Discovery are used. These are DNS-based service discoveries. Um, so then the next set of challenges is the coordination challenges. So coordination challenges among the nodes is mainly due to the network failure and the race condition. Some nodes might go network failures maybe because some nodes might go offline uninterruptedly and race condition. Multiple nodes are trying to modify the shared resources that can lead to inconsistent state of the data. So how do we overcome the coordination challenges? So the techniques to overcome the coordination challenges is failure detection. Detection of failures is critical in maintaining the system reliability. So the reliability of the system is dependent on the failure detection and recovery. So hardware mechanism is used wherein we do health checks, right? Like in the load balancer, we have a health check API to call to keep that the node is alive or not, and the leader election algorithm. So basically in Kappa, if you see, the zookeeper is the one who elects the leader and manages the rest of the nodes for consistency among the data. Okay, so and then the data replication part when it comes to DB, data replication is one major factor, right? Like primary replication. There are two different model. One is primary replica model and the multi-leader replication model. So primary replica model, where is one of the primary nodes accepts only writes and the multiple replica serve reads. So basically, you will have one one major database that is the primary, which will accept only the write, and then in the background it will do a cascading to the other replicas of which are considered as read replicas. So the data replication, so the reads for that particular read queries are fired to that particular databases. So another model is multi-leader application. So this is used in high availability scenarios where multiple leaders accept rights for maintaining high availability. Okay. The other set of challenges are the scalability challenges. Scalability is nothing but in a distributed system, you can scale the system as the resource usage increases. You need to scale to manage the load bearing on the system. So scalability is a common uh, feature of the distributed system. So what are the challenges faced by the scalability? So basically, how do we the key scalability patterns are um, microservices behind the gateway. So one is like breaking down the monolithics into microservices, allowing it to independently scale, and you have so this is like a strangler pattern where um, you break down the monolithics into multiple microservices, and you have a API gateway in front of it, which uh, which routes the request to the correct microservices. So that is one key scalability pattern, and another one is load balancer. So load balancer distributes the request across multiple servers, preventing workloads. There are different types of load balancers. Round robin assigns request sequentially. Least connection is like routes the traffic to a least busy server. It identifies which of the server is least busy, and then it will transfer the request to that particular server to handle the request. And geographical load balancing, where it routes the request based on the nearest server available or the data center available. And then the another scalability pattern is functional decomposition with CQRS. So CQRS is the command query responsibility segregation pattern, wherein it separates the reads and the writes operations into different services. So read heavy workloads use denormalized views to read the to call the read request, and write heavy workloads are optimized for consistency. This is mainly used in case of where you have a write request versus the read request. So we functionally decompose the CQRS pattern talks about decomposing the read request with the write request so that you both are in harmony. Okay, so this is about the scalability challenges. The last challenges what is about is the resiliency challenge. Resiliency is nothing but the system's ability to recover from failures and continue functioning. So in a distributed system, how resilient your system or your application is. So there are different resiliency techniques available. So timeout. So basically, we don't have to every request you make should have a particular timeout so that you don't have to wait indefinitely for the slower responses. So the request has to timeout and then the retry. So request failed request should be retried. So basically, we should be very careful when you are doing retries. Basically, you can do retries in case of a network failure or 500 errors or some error in the system. Based on the error codes, you can do a retry, and with exponential back off. Mm, okay, and then implement the circuit breaking. So we have multiple circuit breakers in Spring 4 as well as Netflix circuit breaker. It has a separate jar file where you can integrate with your microservices, right? Circuit breakers. It stops sending requests to failing services until it recovers. So circuit breaker is another one pattern wherein one of the pattern of the microservices, right? Where you can uh, limit the usage, limit the request, and provide upstream services with proper responses. So load shedding is dropping the low priority request when overloaded. So we can prioritize which request is more, which service uh, has more priority. If there are multiple requests being fired to a service, the service can prioritize which requests are more important, and then we can distribute the load in the load balancer as well. And then rate limiting, restrict the API call per second to prevent abuse. So we can provide a rate limiting like based on the resource usage. Like if you are constrained on the resources, right? Like you can put a rate limiting so that I can accept only this many requests at a time. These many request connections can be held at my server. So you can define that rate limiting. Bulkheads. Isolate failure. So this bulkheads is very ideal in case of components where the which can take down the whole system. So it should be like we need to isolate these components and group them together so that you don't crash the entire system because some of the services are entirely dependent on them, right? Like those needs to be isolated and manage the request and manage the request within constraint to that particular uh, this one because it could take the whole system down, right? And then the health checks automatically detects the failing of the nodes and then you know um, make the server down. So you can it's less like you have a load balancer and then you have a node with the load balancer keep firing the health check queries for each of the nodes when when the node goes down. mm, you have the load balancer has the ability to bring back the other nodes until so it is like a self recovery of the node if in case some failure happens. So it keeps triggering the health checks every time. So those are all these three are the these four are the major challenges in the distributed system and their techniques to encounter. And yeah, I think we covered most of the things. Yeah, thank you for watching my channel and I'll be keep posting these system design related challenges, system design related videos. So keep watching. Thank you.